Okay, well, besides all the jumpers in there, it's actually pretty clean here. That big relay turns the plate transformer on. That little one right there, that plug-in one, there you go. That one comes up here to the front, right here. That's a PTT. There's I think I got a 30 amp fuse in there right now. That's the main line. The way I've got it hooked up is the main power comes in, and this is number 14 wire, the red stuff, goes over to the relay directly to the transformer. Doesn't go through a switch in the front, so I'm trying to minimize the lead length. So you can see the two red wires coming off that big relay. A lot of, here, let's get the light over there, you go. It goes down to the other two red wires. See what I mean? I use this little relay to pull the big relay in, and that little transformer right there. Now I've got a diode, as you might be able to see right there across that little relay, because it's DC. And here's the DC supply right there. It's a little wall wart thing. And this one right here, this is a 24 volt AC that pulls a big guy in. So like I said, I'm trying to minimize the wire length and not actually run it through a toggle switch. Those four diodes right there are 20,000 volt PIV 2 amp. This is just a terminal strip down here. Like I say, it looks a lot better, but I've got a bunch of jumpers in here because I'm going to do something dangerous and tickle the dragon's tail, as you might say. What I'm going to do is the modulator is actually complete. One of the things that's missing is I don't have a ground out here. A ground strip to ground it. I always put like a, I don't know, at least a 1032 with like a wing nut on them to strap this one to the ground, you know what I mean. I never rely on metal to metal. Well, what I've got right now, right here, this is the output of the modulation transformer. All that stuff is all hooked up in there. That's actually complete. What's the power supply choke? It's got two 2.5 Henry chokes in series at 700 milliamps. Okay, anyway, I want to power this thing up and put high voltage on it for the first time, and I don't think it's going to blow up. It is plugged in. It's that orange plug right there. That one right there. I've been testing it a number of times. What I do to test it is I disconnect this wire right here from the primary, and that way I can make sure all the relays are working. Like I say, that 12 volt relay pulls in the big relay. In the front, this turns on. This is an inline AC switch. Lights up the filaments. We have filaments. The 31000Z. I've got a pair of 4400s in it right now. I got a number of 4400s and a number of 3400Zs, but I'm just going to play with these first. What I actually am looking to see is the high voltage come up under a load. I have tested the high voltage on before into a resistor, and then this right here enables. With it down, it's bypassed, but when that one is up, see, I even got a switch across. We got one of those kind of things across it, except the side broke out. I got some more. Anyway, and then when I press this, the high voltage should come up, and I should get some resting plate current right here. I've never done this. There's no high voltage on the RF amplifier up here yet, but sometimes I just have to do little experiments like this to see progress. There's also no bleeder on it, and I don't think I'm going to put a bleeder on it because all these zero bias triodes draw current all the time, so I'm going to use them as the bleeder. Oh my God, am I ready for this? Not really, but I'm going to do it anyway. When I press this right here, I'm just going to pick it up in my hand and press it. The high voltage will come up and let's see what happens. Ready? 3, 2, 1. I don't know if I really want to do this, but I guess I got to. Okay. Oh, it came out. Oh, it did. Oh, hallelujah. Hallelujah. Look at there. Look at there. 3,600 volts. That's good. That's a little high. I want it more like 3,000. There's resting plate current. This is calibrated to 1 amp. Thank you guys for helping me the other day. I don't know why. I just couldn't figure it out. So the 20 is 200 milliamps. It's scaled to 1 amp. So that's about 140 milliamps. Oh yeah, you can see the tubes turning red. This color makes them look kind of orangey. But darn thing's working, isn't it? Yeah, no, that's good. That's a good resting plate current. That's a good high voltage. I got some taps on the transformer to change. And I got high voltage. Because I can see them orange. There's no cats in here with me right now. I made sure of that because I don't want to fry my kitty cats. And when I let go of this is what I'm saying. I don't think I need a bleeder resistor because watch. Right? I'll take your... There you go. Whew. No, this is real progress. I have to have a little encouragement points here and there. Wow, I'm impressed. I'm going to work all night now. It's only 1:30. Love it. Okay. All right. Turn this thing off. Turn that off. Okay, I'll upload this one for your entertainment. Unplug this thing. And, oh yeah. Do you think I need, I have a diode, I think I mentioned that. I have a diode across the DC relay. The AC relay, I think, should have this kind of a RC circuit. This is a, what is it? This is a 220 ohm and a 0.5. Would you put that across the coil? Would you put it across the contacts of the relay? I really do want your thoughts on this. I know a relay across a DC coil can be an absolute necessity. Oh yeah, another thing I want to talk to you about. The old way, see that resistor right there? That's ground. The resistor is jumpered out right now. So the DC plate current meter is going to be between there and ground. But I don't think it's going to work exactly the way I want it to, because isn't that going to measure the sum of it's going to measure the sum of all of the currents. It's not going to measure just the plate current. See, I've got a test point right here where it says grid meter. It's kind of washed out. Yes, it says grid meter. That takes the I think the cathode. Well, hell, now I don't remember what it does. No, I think it takes the grid to ground. Yeah, it's bypassed at the socket for RF, and then this actually takes the grid to ground. So this is going to for real be grid current. I got to change that little milling connector out because that'll arc, and I'm going to build a pi network inside to tune what comes into this SO239. That's just a mystery hole from somewhere, like whatever. But since I'm using a common power supply, I usually use separate power supplies, but since I'm using a common power supply, and I put a meter from the top of that resistor across it, basically what I'm doing. See that point right there is really not a high voltage point. That's really the ground point. You know, that's where the meter will go. I think I'm about to do something weird here that's not going to quite work. Anyway, I just put a little bit of goop on the back of that thing and then solder some wires on it. That's the way I've used these little wall wart things before for this. That's the 12 volt one too, for that relay right there. And that means that I can plug this thing directly into my 7300 or whatever and not blow it up, because you know how all these older devices that we have, most all of them use like the bias voltage, somewhere between 110 and 170 volts, because they went through relay contacts for PTT. All these modern day relays say something like maximum voltage like 16 volts at 500-600 milliamps. So just in case it gets plugged in, I got two extra. The two bottom ones down there have fuses in them. They're fusing the filaments and stuff. The two top ones are not used yet. And then there's that big guy right there. I like those BAE fuses. They blow really good. I think it's got a 30 in it now. I'll probably change it to a 20. And that's it. I think you've seen the Pi network. Alright. Well, I'm real happy. I'm even still alive. Tickling the dragon's tail.